Hello again, everyone. This week in WBS 7, we are learning how to reduce the duration of a project. Now, there's a supreme irony about what you're learning this week. What you're learning how to do in practice, you should avoid doing whenever possible. Why? Well, we've seen how the probability of actually pulling off a project drops rapidly given the PERT analysis. It drops rapidly if you remove any time from a project at all. For example, remember the 3-point estimates and how they led to an average, a weighted average for the estimate of the project duration. And if you remove any time from that, you're going to go below 50%. The estimated average time of achieving a project schedule based upon 3-point weighted average analysis using PERT, that average or estimated time has an only 50% probability. So you remove time from that, the probability goes down. So now here you are being asked to reduce the duration of a project, typically by adding funding, adding resources, either people or materials. And it begs the question, well, if you could do that, why didn't you do it earlier? Why didn't you do it as the beginning of the project, as part of the project plan? Well, you probably didn't do it because of risk and also because of cost, which is why you avoided doing it in the first place. But now you've gotten a situation where maybe your project is behind, maybe there's an estimation problem, and you have to try and think of ways to catch up. So you're going to add resources to certain activities in your project to try to reduce the duration. But as we've seen, trying to do that increases risk. What does this mean? It means you may spend more money and put a lot more resources on the project and end up still being late, maybe even more late. So it's something to consider. This is why I say let's learn how to do this, but you should avoid doing it if at all possible. Just like let's take a quick look. This comes between scheduling resources, which we did last week, and our final major topic, which is earned value, is what we cover next week. So what's the rationale? So you're trying to reduce time, and you're reducing time and trading that off for money. Remember the triple constraint. If you want something faster, it's going to cost you more. Why would you want to do that? Well, maybe you're launching a project, a consumer electronics product, for example, and you have to get it to the market for the Christmas season. And if you don't make the holiday season, your project won't be profitable, and you're behind and you're trying to catch up. So there could be a lot of reasons for this. Now, let me say there's another reason, another methodology of trying to reduce project duration, and that's trying to eliminate scope. For example, I'm sure many of you have tried Microsoft Windows Vista and not liked it very much. Some say that Windows Vista is what was supposed to be Windows 7, but a lot of scope got left out of that so they could bring it to market sooner. It wasn't well accepted, but it did help them keep their market share until such time that Windows 7 could come out. So keep in mind, you can add resources, you can add funding, you can put more people on a project to try to get it done faster. It's risky, it may not work, and another approach is reducing scope. Okay, what do? You add people, you could maybe schedule overtime, do it twice, fast and correctly, like Microsoft did with Vista. You could also try reducing project scope, which is typically your first choice if you can get away with it. And it also mentions compromising quality. That I also view as a way of reducing scope. Now, the purpose of this module is to show you that if you must reduce the project schedule, what you should do is try to reduce activities that cost less first, to try and get more bang for your project reduction buck, as it were. So go to the lowest cost first. And it also, a second principle is that given that you're spending more money to reduce the schedule, but also as the schedule reduces, you're going to spend less indirect cost. For example, let's say building rental. If you're inhabiting a building during your project, if your project is shorter, you're going to spend less per day on that building. That's an example of indirect cost. So you're going to spend more to shorten the project, but if the project's shorter, you may spend less in indirect cost, and there's a sweet spot in balancing off the direct and indirect cost. So the two principles at work here are find the least expensive activity to reduce first, and then you try to optimize by reducing as much as you can that minimizes indirect cost and balances indirect and direct cost. All right. You, in a typical project, you will be asked to go do this, to find the direct and indirect cost and figure out what are the lowest direct cost activities to shorten the project duration. You'll have to gather that information yourself when you're managing a project, but for the purpose of this course, it's given, and you're just carrying out the calculations. Here's the example of finding the sweet spot. Project duration. Notice that as the project gets shorter and shorter, your direct costs go up. That's the dashed line with the squares. The shorter it gets, the higher your direct cost. However, the longer the project is, the higher the indirect cost. For example, you got to pay for the building. So this shows successive schedule reductions that optimize the cost point time, which is a balance of direct and indirect cost. Okay, and let's just take a quick look at an example. First of all, you find total direct cost, indirect cost, you sum them, and then you look at the trade-off in the cost duration graph. Now, which activities do you shorten? Shorten activities with the smallest increase in cost per unit time. There's a lot of assumptions being made here, and not all of these assumptions are correct. For example, I've had some students say, well, you suggest I should reduce an activity that's the least expensive to reduce. Yes, that's generally correct. Well, what if that is the most risky one? Maybe I should spend a little bit more money on a less risky activity. That's true, and that's a possibility you must consider in your particular context. But in this lesson, and in just typical project text on reducing project duration, the idea is that what you're trying to do is minimize time and spend as little money as you can in doing so. All right. Now, often cost reductions are given in terms of the slope of the cost reduction graph. For example, what is a cost reduction graph? Well, it shows duration and activity cost. You know, and slope is rise over run. You're looking at the change in duration and the change in activity cost. So what this comes down to as a practical matter is the cost per unit of time that you reduce your schedule. For example, your normal cost, and this is typically what you're given in a crash problem, you're given a normal cost, normal time, your crash cost, and your crash time. So this shows in activity A, you've reduced your duration by 1 unit because you went from time 3 to time 2. And since the slope, the cost per unit time is $20, you have added $20 to the total cost. All right, so typically in every example, in every problem, you're given the maximum units of time you can reduce, the cost for each unit of time. For example, B has 2 units of time, which is the maximum, and the cost per unit of time is 40. So you've reduced it by 2 days, and you have 160 instead of 80 of cost because you've added 2 times 40 to it. Okay, now there's several examples in the text that take a network diagram and go step by step where you analyze what you can reduce. Now remember, if you're trying to shorten the duration of the project, you need to focus on those activities on the critical path. If you reduce an activity that's not on the critical path, you're not going to reduce the overall project. And you also go to the lowest cost first. So in this example, we reduce A first. It's on the critical path, and it's lowest in cost. The next activity you move to is D. D is in parallel with C. D is on the critical path, C is not, but if you reduce it by 1, you're going to reduce the overall project by 1 unit of time. But notice what happens when you do this. When you reduce D by 1 day, both C and D will be on the critical path. And if you have more than one critical path, that's 2 paths you have to manage that cannot change at all. And if you change them at all, you're going to lengthen the overall project. So you've added risk to your project. So you just carry through this. Notice C and D are now on the critical path. Now you look at F, you reduce F. Then if you're going to reduce any further, you have to take into account this other path. So there's 3 activities you have to reduce. So you could see right away this gets complicated, this gets expensive, and it adds more risk. So what are the takeaways for this week? Do not crash projects unless you have to. It begs the question, if you could reduce a project by adding more money, why didn't you do it in the first place? You didn't because it cost too much and it's very risky. Look for alternatives, such as reducing scope if you can. But if you must try and crash a project, according to the direction you're given this week, you should focus on trying to get the most bang for your buck. Reducing first the activities that have the lowest cost per unit time. Reduce those first. But recognize that as you do reduce it, you may add multiple critical paths and may get to a point where all paths in the project are critical, which means you're going to add a lot of risk and management headaches. And it's entirely possible you can do all this work and you can still fail to deliver on time. You may end up spending more money and also being late. So it is really risky, but this gives you the procedure to do it if you must. So that's WBS 7. Remember, we have one more major topic next week, and that's earned value, and then we'll be at the end of the course. So thanks for hanging in there so far, and we'll see you in the discussion threads this week.